So there are a couple different formulas that we can use to find the correlation. The definition of correlation is the correlation of security K with the market is equal to the covariance of K with the market divided by the product of their standard deviations. So divided by the standard deviation of K times the standard deviation of the market. Since the table gives us the covariance of security K with itself, which is its variance, and the covariance of the market with itself, which is its variance, we can easily find the standard deviation for each. Because remember, the standard deviation is nothing more than the square root of the variance. But we don't know the covariance of K with the market, so we can't use this definition directly to find the correlation right away. We have to do something else first to find the covariance. So the problem tells us that we can find the beta of security K. So we should use the following formula for covariance. This formula is given to us in our handout. It says the beta of security K is equal to the covariance of K with the market divided by the variance of the market. Again, we know the variance of the market from the table. So if we find the beta of security K, we'll have everything we need. So we can use CAP-M to find the beta of security K. Remember, CAP-M tells us an equation to help us find the expected rate of return on some security. So CAP-M tells us the rate of return on security K equals the risk-free rate plus the return on the market minus the risk-free rate, and this difference right here is sometimes referred to as the market risk premium. Sometimes that's all we'll be given, and we'll just know that that is that difference. It's the same thing. Times, we multiply the market risk premium by the beta of the individual security. And again, that beta is a multiplier. It measures how risky the security is relative to the market. So we plug in all of our numbers, and we just solve for beta. So we're given that security K expects to return 16.96%, and the risk-free rate is 4%. The return on the market is 10%. We plug in the risk-free rate right here again, and if we rearrange this equation and solve it for beta sub K, we find the beta on security K is equal to 2.16. So now we need to solve for the covariance of K with the market. So again, here's the equation that relates beta with covariance. The beta of K we just found, the covariance we're looking for, and the variance we know from our table. So we plug in those numbers, and then we rearrange and we solve for the covariance, and we see that the covariance is 0.0054. So finally, we can solve for the correlation between K and the market, since we know the covariance. Again, the correlation, this equation relates correlation and covariance. The correlation between K and the market is equal to the covariance divided by the product of their standard deviations. And again, the standard deviation, we just take the square root of the variance, and we know both of their variances from the table given. So we plug in all of those numbers, noting here that we are taking the square root of the numbers given in the table, and the correlation we find is 0.90.